Good day. I'm Lo Hung. My number metric is AA201211. Today I'm going to present the solution of our circuit theory group assignment question 1 and the simulation result of the circuit. In the diagram is the circuit that we need to solve it. We need to find the current flow of I1 and I2. Other than that, we need to find the voltage of resistor R4 and the power supply by the voltage source. Solve this question using mesh analysis method and separate the circuit into three different loops. We apply KVL to get each loop equation. In loop 1, since the definition of KVL is algebraic sum of all voltages within the loop must be equal to 0, so we apply IA as our mesh current that is imaginative and not measurable directly, and apply Ohm's law in the resistor I1. The resistance value is 35 times IA plus 10 times IA minus IB plus 125 IA minus IC plus 26 IA equal to the voltage source 500 volt. So we can get the equation 1, there is 206 IA minus 10 IB minus 125 IC is equal to 500 watt. Loop 2, here our mesh current is IB. So we can apply KVL and Ohm's law. We can get the second equation is negative 10 IA plus 100 IB minus 60 IC is equal to 0. As the same, in loop 3, our mesh current is IC and we apply KVL and Ohm's law on it, and we will get the third equation is negative 125 IA minus 60 IB plus 325 IC is equal to 0. So we can find the value of IA, IB, and IC using the simultaneous equation, and we will get the answer that is IA is equal to 3.671 ampere and IB is 1.442 ampere, and the final for IC is 1.791 ampere. We need to find the answer for the I2, current flow of I2 that is equal to IA minus IC. So the answer is 1.880 ampere. So next we need to find for the current flow I1. Actually I1 is equal to IB, our mesh current IB, so equal to 1.442 ampere. Next, we need to find the potential difference V for the 60 ohm resistor. So the solution is IB minus IC times 60 ohms using the formula V equal to IR, Ohm's law. So we can get the answer is negative 20.94 watt. Lastly, we need to find the power supply by the voltage source. So we apply the power formula E equal to VI. So that's 500 times negative 3.671. The final answer is negative 1835.5 watt. Why have negative power here? Because power is a sign quantity. Negative power just represents power flowing in the opposite direction from positive power. Now we proceed to our simulation step. I using multi-sim software to verify my solution answer. Here is our simulation circuit. So we need to find for the current flow of I1, for the current flow for I2, we need to find the potential difference of R4 here. So here is the positive, here is the negative, and find the power of the voltage source. So power of the voltage source. Okay. So we start the simulation here. Here we can see for the I1 is 1.44A. So 1.44 ampere. So that is proof. This proof that the answer for my solution is correct. So for the I2, the current flow for for I2 is 1.88 ampere. So there is also proof that my answer for my solution is correct. So for the here, here for the potential difference of the resistor here is negative 21 watt. So also prove that my solution answer is correct. So finally we need to see for the power, the power of the voltage source. So here is negative 1.84 kilowatts. So it's same, the answer is the same as my solution. So in this simulation that prove that and I can verify that my answer in my simulation is all correct. So that's all from me today. Thank you very much.
Hi everyone, I'm Chan Yushuan with matrix number AA200602. I'm a student from University Tun Hussein Malaysia UTHM. In this video, I'll talk about nodal analysis and how to write nodal equation. So let's get started. We are asked to solve this circuit by using nodal analysis. To form nodal equation, we have to use Kirchhoff current law KCL, which is current in equals to current out. Since this circuit has 3 main nodes, so we have to form 3 nodal equations, then solve them simultaneously by using calculator. To prove my answer, I'll be using multisim stimulation.
Hello everyone, my name is Lim Kian An, matric number AA200825. So today, I am going to show you guys how to solve this question. So for the part A, we first need to apply KVL for the supermesh and the loop to find the first and second equation. Then we applying the KCL at node A and node B to find the support equation. So we substitute the third equation into first and second equation to find all of the current. Then for the part B, here I rearrange the circuit into like this and find the voltage that across dependence current using VIR. Find the V1 and V2. Then we find all the power for all components and we total it. So it proved that the power developed is equal to the power dissipated. Here we get 0 and 0. So next, I'm going to show you guys to check the answer using the multisim to do the stimulation.